Assalamualaikum warahmatullahi wabarakatuh dan selamat petang. Kita bertemu lagi semula berkenaan tajuk kita Network Structure Cabling LA1 Identify Network Cabling. Dalam tajuk ini, tujuan pembelajaran tajuk ini, pelajar-pelajar mestilah boleh terangkan jenis-jenis topologi. Yang kedua adalah terangkan kebaikan dan keburukan topologi. Terlebih dahulu, sebelum saya memulakan tajuk berkenaan dengan topologi ini, saya cuba terangkan apa itu topologi. Okey, apa itu topologi? Topologi atau network topologi bermaksud corak susunan atau layout pattern pelbagai elemen yang terdapat di dalam rangkaian komputer. Maknanya kalau dia nak kita ceritakan adalah fungsi dia adalah menghubungkan dua komputer atau lebih. Bagaimana dia kita panggil dia sebagai topologi. Terlebih dahulu, cerita pengenalan berkenaan dengan topologi. Topologi ialah cara penyambungan fizikal bagi sistem rangkaian komputer. Struktur laluan dan switch yang menyediakan hubungan komunikasi di antara nod di dalam rangkaian. Okey, yang seterusnya adalah yang ketiga, setiap topologi mempunyai struktur sistem pengkabelannya yang tersendiri. Okey, untuk pengetahuan awak, topologi ni dia ada struktur pengkabelan dia yang tersendiri. Topologi terbahagi kepada dua. Yang pertama, topologi fizikal. Apa tu topologi fizikal? Okey, topologi fizikal ialah satu rangkaian merujuk kepada konfigurasi yang terdapat pada kabel, komputer dan lain-lain perihal. Yang kedua, topologi logikal. Apa itu topologi logikal? Topologi logikal merupakan kaedah yang digunakan untuk memindahkan informasi atau maklumat antara satu komputer dengan satu komputer yang lain yang terdapat dalam stesen kerja. Okey, maknanya ada dua topologi yang perlu anda tahu, iaitu topologi fizikal dan juga topologi logikal. Okey, yang seterusnya, terdapat dua jenis sambungan yang membolehkan lebih dua sumber berinteraksi. Bagaimana dia berinteraksi? Okey, dalam topologi ini terdapat dua. Yang pertama, point to point connection. Yang kedua adalah multi point connection. Okey, kita pergi satu persatu. Start daripada point to point. Okey, apa tu point to point connection? Point to point connection adalah menyediakan penyambungan berterusan di antara dua buah sumber. Contohnya, penyambungan terus dua buah komputer. Okey, itu kita panggil point to point connection. Manakala multi point connection adalah menyediakan perkhidmatan tiga atau lebih sumber di dalam sesuatu sistem jaringan tersebut. Okey, itu berkenaan dengan penerangan berkenaan point to point connection dan juga multi point connection. Terdapat 6 jenis topologi. Apa yang ada di dalam 6 jenis topologi? Okey, yang untuk ni awak-awak semua perlu ingat. Okey, yang pertama, topologi bus. Yang kedua, topologi star. Yang ketiga, topologi ring. Yang keempat adalah topologi mesh. Yang kelima, topologi hybrid. Dan yang terakhir sekali, topologi tree. Alright, ada 6 jenis topologi. Kita pergi satu persatu. Terlebih dahulu, topologi bus. Apa tu topologi bus? Topologi bus menggunakan satu kabel yang panjang menyambungkan ke semua sumber di dalam satu network. Maknanya dia menggunakan satu kabel yang panjang untuk menyambungkan setiap network. Alright. Message atau data yang dihantar akan pergi kepada semua PC yang berada di dalam sistem rangkaian sebelum sampai ke PC yang sepatutnya menerima message tersebut. Okey, itu bagi pengenalan berkenaan dengan. Berikut adalah gambar rajah bagi topologi bus. Okey, kalau kita perhatikan macam mana pergerakan kabel daripada satu komputer kepada komputer yang lain. Seterusnya, kelebihan topologi. apa yang ada pada kelebihan pada topologi bus ni. Alright. Topologi bus, kelebihan dia yang pertama adalah pemasangan amat mudah dan murah. Ini yang paling penting sekali. Pemasangan mudah, lepas tu murah. Yang kedua, mudah untuk menambah not, iaitu dengan menyambung not baru secara bersiri. Okey, kita nak tambah not, kita boleh mudah, iaitu kerana sambung secara bersiri. Yang ketiga, sesuai untuk rangkaian yang kecil. Maknanya dalam area yang kecil. Okey. Seterusnya adalah kekurangan topologi bus. Apa yang kurang? Apa keburukan topologi bus ni? Yang pertama, sebarang masalah pada mana-mana node pada rangkaian tersebut berupaya menjadikan keseluruhan rangkaian tersebut gagal berfungsi. Maknanya satu node rosak, maknanya yang lain pun gagal berfungsi. Okey. Yang kedua, titik pemula atau penutup diperlukan pada dua penghujung tulang belakang kabel tersebut. Maknanya kat backbone tu kena titik permulaan dan penutup perlu dia ada. Dan yang seterusnya, sukar untuk mengenali permasalahan yang dihadapi jika keseluruhan sistem rangkaian itu gagal berfungsi. Maknanya dia agak sukar untuk kita detect dekat mana jika dia ada kerosakan. Alright. Topologi bintang ataupun star. Topologi bintang menggunakan perkasan pertengahan yang dipanggil hub. Okey, untuk pengetahuan awak, topologi bintang ni dia menggunakan hub. Alright. Yang kedua, semua sumber di dalam network atau sistem jaringan akan bercantum dengan menggunakan hub yang menjadi penghubung di antara sumber-sumber tersebut. Maknanya hub ni merupakan yang paling penting sekali dalam topologi bintang. Alright. Seterusnya, semua mesej yang disampaikan akan melalui hub sebelum sampai ke destinasi yang sepatutnya. Kita pergi kepada gambar rajah topologi bintang. Berikut adalah contoh gambar rajah bagi topologi bintang. Okey, apapun bila kita tengok pada topologi bintang ni, kita tengok ada hub. Maknanya semua sambungan kepada setiap PC itu disambung melalui hub. Okey, seterusnya kelebihan topologi bintang. Okey, kelebihan topologi bintang yang pertama, mudah untuk ditempatkan ataupun diinstal dan dipasang kabel untuk wiring. Yang kedua, rangkaian tidak akan terganggu apabila salah satu daripada sumber dialihkan. Makna tak ada gangguan walaupun kita alihkan. Alright. Yang ketiga, mudah untuk mengesan kesilapan dan kejahatan yang berlaku dan memindahkan perkasan yang rosak. Maknanya mudah kita nak detect dekat mana ada kerosakan ataupun kesilapan. Seterusnya adalah kekurangan topologi bintang. Apa ada kekurangan pada topologi bintang ni? Memerlukan kuantiti kabel yang panjang berbanding dengan topologi bus. Okey, memerlukan kabel yang panjang. Yang kedua, jika hub atau konsulator gagal berfungsi, node juga turut gagal untuk menjalankan tugas. Maknanya apa yang disambung hanya pada hub. Jadi apabila hub rosak, maknanya dia tidak berfungsi. Yang seterusnya, kos yang diperlukan adalah lebih tinggi berbanding dengan topologi bus kerana melibatkan kos konsulator yang agak mahal. Alright, dan seterusnya, yang keempat, apabila komputer host rosak, semua komputer akan terjejas menyebabkan sebilangan besar kuasa pengkomputeran. Okey, ini adalah kekurangan topologi bintang. Yang seterusnya, topologi yang ketiga adalah topologi cincin. Topologi cincin memerlukan beberapa sumber yang dicantumkan menjadi satu bentuk bulatan. Dia menjadikan satu bentuk bulatan seperti cincin. Okey, mesej yang kedua adalah mesej atau data dihantar dari satu komputer pada yang lain dengan satu arah. Dia melalui satu arah saja. Dan seterusnya, apabila sesebuah komputer menerima mesej atau data yang dihantar kepadanya, ia kemudian akan mengubah suai dan mengembalikannya untuk menunjukkan ia telah menerima mesej tersebut. Okey, ini penerangan berkenaan dengan topologi. Selain daripada itu, apa lagi? Topologi cincin membawa kapasiti medium iaitu 1 megabit per second sehingga 10 megabit per second. Dia boleh membawa data. Okey. Seterusnya, yang kedua digunakan untuk internet sistem iaitu 10 megabit per second. Kos yang mahal berbanding dengan UTP. Mampu menghalang gangguan signal daripada luar. Jarak penyambungan yang jauh dan yang terakhir sekali menggunakan isyarat elektrik untuk menghantar data. Alright. Ini adalah gambar rajah topologi cincin. Okey, kalau kita tengok dia ada satu bulatan. Dia berbentuk cincin. Kelebihan topologi cincin. Apa kelebihan topologi cincin? Yang pertama adalah jika komunikasi terputus di antara dua sistem bersebelahan, satu lintasan alternatif dia di antara dua tempat ini boleh digunakan. Okey, yang kedua mudah ditempatkan ataupun diinstal dan dikabelkan wiring peralatan. Yang ketiga mudah mengesan kesilapan dan kerosakan dan mengasingkan peralatan yang rosak. Seterusnya, kekurangan topologi cincin. Apa yang ada pada kekurangan topologi cincin ni? Yang pertama, memerlukan kabel yang lebih panjang sama dengan topologi bintang. Okey, dia memerlukan kabel yang panjang sama seperti topologi bintang. Yang kedua, jika hub atau konsulator gagal berfungsi, not berkenaan juga turut gagal berfungsi. Dia sama macam topologi bintang. Maknanya jika hub rosak, yang untuk lain pun tidak berfungsi. Yang seterusnya adalah topologi hybrid. Topologi hybrid ni topologi campuran di antara tiga topologi. Okey, dia menggabungkan tiga topologi. Apabila sistem rangkaian bertambah besar, topologi jenis ini sering digunakan. Maknanya jika network tu besar, topologi hybrid ni biasa akan digunakan. Ia merupakan beberapa sistem rangkaian berbentuk bintang disambung kepada workstation. Topologi bus sebagai tulang belakang ataupun backbone sistem rangkaian untuk topologi hybrid ni. Maknanya dia punya backbone dia menggunakan sistem topologi bus. Maknanya di dalam topologi hybrid ni dia menggabungkan tiga topologi iaitu topologi star ataupun bintang, topologi cincin dan last sekali adalah topologi bus. Dia gabungkan kepada tiga. Ingat, kalau topologi hybrid dia gabungkan kepada tiga topologi. Kelebihan topologi hybrid ni, yang pertama adalah lebih banyak peranti boleh dihubungkan ke hub pusat. Yang kedua, kerosakan boleh diperkecilkan. Dan yang ketiga, keutamaan boleh diberikan kepada komputer-komputer dari segmen tertentu. Ini merupakan kelebihan topologi hybrid. Topologi mesh. Apa itu topologi mesh? Apabila peralatan disambung ke semua node sistem rangkaian yang ada, dengan kata lain, sekiranya terdapat 10 peralatan di dalam sistem tersebut, maka satu peralatan akan disambungkan secara terus kepada 9 peralatan lain. Begitu juga sebaliknya. Maknanya sekiranya ada 10 peralatan dalam tu, satu tu peralatan itu sambung terus. Yang untuk lain, yang berikutnya akan disambung yang akan seterusnya lah. Kalau balance dia lagi berapa? 9. Kalau 20, balance lagi 19 tu dia akan disambung terus. Okey, kebaikan topologi mesh ni yang pertama adalah setiap pautan boleh mengendalikan muatan datanya tersendiri, maka tiada masalah kesesakan trafik. Maknanya tiada masalah kesesakan. Yang kedua adalah lasak. Jika satu pautan rosak, pautan yang lain tidak terjejas. Maknanya dia ni tahan. Maknanya dia lasak. Yang ketiga adalah lebih selamat. Hanya penerima yang menerima data. Hanya data yang akan tu pergi kepada, contohnya kepada satu PC sahaja. Yang seterusnya, yang keempat, pengesanan kerosakan adalah mudah. Kita nak kesan, nak detect dekat mana adalah mudah. Yang seterusnya adalah kelemahan topologi mesh. Bilangan kabel atau port yang diperlukan adalah tinggi. Maknanya sebabnya setiap PC ataupun tu memerlukan satu port. Kalau kita pakai 20 port kita kena ada. Itu kelemahan pada topologi mesh. Pemasangan dan konfigurasinya semula sukar. Dia agak sukar untuk kita membuat pemasangan. Dan yang terakhir sekali adalah dia adalah lebih mahal, okey, untuk topologi mesh ni. Okey, seterusnya untuk lebih detail saya akan tunjukkan awak semua video di mana bagaimana penerangan berkenaan dengan topologi ni lebih detail dan juga penerangan bagaimana pergerakan dah bergerak daripada penghantar kepada penerima. Saksikanlah video.
Hey guys, this is DG. Today we will learn what is network topology, its types and how they differ from one another. So let's start. Network topology is how computers connect or relate to one another in a computer network. It is of two types, physical topology and logical topology, where physical topology describes the way computers connect with the help of cables. Logical topology describes the way data flows from one computer to another within a computer network. The most common computer network used to interconnect physically distributed computers is local area network, which has three main topologies: star topology, bus topology and ring topology. Others are mesh topology and hybrid topology. Please note, the data in the network layer is in the form of IP packets. IP packets are packed into frames in the data link layer. Physical layer then transmits the frames into the transmission media. So, in a computer network, data moves from one computer to another in the form of frames. The same term will be used in the further discussion. Starting with bus topology. In a bus topology, computers connect to a shared central cable called bus with taps and drop lines. Shared means that all connected computers use the same cable for data frame transmission. Taps are the connectors and drop lines are the cables running in between computers and the bus. In this topology, if a computer sends data frames to a second computer, all other computers connected to the same central cable also receive the frame. That is, other computers can hear what the first computer is saying. However, only the target computer accepts it. Others reject the frame by checking the destination MAC address in the received frame. Suppose you are distributing prices as per the results of a competition. You ask Ram to come on the stage for his reward. So only Ram will go and collect the prize. Same is in the case of bus topology. Only that computer accepts the frame to whom it is addressed to. Since bus topology requires less cabling, so it is easy to install and less expensive to implement as compared to other topologies. However, with the increase in the length of central cable and the increase in the count of taps, the strength of signal decreases. So, only a limited number of computers can be connected in bus topology. In this topology, all computers depend on the central cable for data frame transmission. So, if the central cable fails, it paralyzes the whole network. That is, bus topology has a very little fault tolerance. Here, a security risk also exists because all computers can hear what other computers are saying on the shared media. In a bus topology, only one computer can transmit data at a time. So, while one computer is sending a file to a printer, other computers have to wait. If other computers too start sending data at the same time, it will collide and corrupt the whole data. In such a case, data should be retransmitted. Therefore, if more computers connect to the same central cable, the network will become slower and also increase the chances of data collisions. It is one of the reasons why bus topology is rarely used in modern computer networks. the collision can be avoided by using an access control protocol. For example, carrier sense multiple access with collision detection. Example of bus topology is Ethernet LAN. Next is star topology. In star topology, computers connect to a central device, a switch or a hub with point-to-point communication links. Point-to-point connection means that there is a dedicated link or cable between the two devices. Other devices cannot use it. In this topology, if one computer wants to send some data frame to another computer, it is first routed to the central device. The central device then either broadcasts or unicast the received data frame towards the destination computer based on the type of the central device used. Broadcast means the transmission of data to all connected devices, while unicast means transmission of data to the target device only. If the central device is a hub, it broadcasts the received frame to all the connected computers. That is, a hub is a multi-port repeater. The frame has a destination MAC address, which is unique to every computer present in a network. So only target computer accepts the frame, others reject it. Since a hub broadcasts the received frame, so it increases unnecessary data traffic in the network. To overcome this limitation, a switch is used as a central device. Every computer has a unique MAC address. A switch stores the MAC address of the devices connected to its ports. It is called a switch table. Since data frame it receives has a destination MAC address and the switch knows that the device with MAC address MAC2 is connected to port P2, so the switch forwards the received data frame to port P2 only. Hence, instead of broadcasting, the switch unicasts the frame. Suppose your computer is connected to a printer with a star topology network. Now you click on print on your computer to print a file. The file is sent to the central device. If the central device is a hub, the file is forwarded to all connected computers. However, only printer accepts it. On the other hand, if the central device is a switch, the file is sent to printer only, that is unicast. Moreover, when the computer is busy in sending a file to the printer, computer A and B can also communicate with each other without affecting the computer-printer link. That is, switched connection allows simultaneous communication. On the other hand, a hub allows only one device to communicate at a time. Please note, if the destination MAC address in the frame is Ethernet broadcast address, then the switch also broadcasts the received frame. In star topology, only one input-output port and one cable is needed for each device to connect to several devices. It makes it less expensive than the mesh topology. It is also easy to reconfigure because we can add or remove devices simply by connecting or disconnecting one cable. If one cable connecting to the central device fails, only one communication link goes down and not the entire network. So, star topology has a good fault tolerance. Fault detection is also easy because we only need to locate a computer which is not receiving data. However, if the central device goes down, the whole network is paralyzed. One more limitation in star topology is the number of computers in a network is limited by the number of input-output ports in the central device. Example of star topology is high-speed LAN. Now, ring topology. In a ring topology, each computer connects to two adjacent computers to form a ring. Data transmitted by one computer moves from one computer to another in a circular fashion to reach its final destination. The advantages of ring topology are easy installation and less cabling. In this topology, data moves in one direction. It reduces the chances of data packet collisions. The ring topology is relatively easy to troubleshoot because we only need to locate a computer who stops receiving data from its upstream neighbor. However, as each data frame has to pass all computers between the source and destination, it makes data transmission slower than the star topology. Since all computers connect to form a closed loop, one fault paralyzes the whole network. It is difficult to reconfigure because we need to break the ring to add or remove the computers. Due to this reason, the physical ring topology is rarely used. Instead, logical ring topology is used. Example of ring topology is token ring. Token ring does not use a physical ring topology. Instead, it uses physical star and logical ring topology in which data moves in a circular fashion. Token ring uses a token passing protocol where a frame called token keeps on circulating on the ring. If one computer has data frames to transmit, it holds the token and transmits the frame. Once the transmission is done, the token is released into the network. A token ring network is deterministic, meaning each connected computer is given access for transmission at fixed time intervals. Therefore, a network can have one physical topology and an entirely different logical topology at the same time. Mesh topology. In a fully connected mesh topology, each device has a point-to-point link to every device in a network. Therefore, if the number of devices in a network is 4, then the number of links or cables each device have is 4 minus 1, that is 3. Now, we have 4 devices. Therefore, total number of links or cables 4 devices have is 4 into 4 minus 1, that is 12. Note that these are simplex links. In simplex links, data can move in one direction only. So, one link is used for sending data and the other is used to receive data from the adjacent computer. Duplex links are the ones where data can move in both directions. Therefore, we can replace 2 simplex links with one duplex link. Hence, the total number of duplex links in the mesh topology is 4 into 4 minus 1 by 2, that is 6. In general, if there are n devices, the total number of simplex links are n into n minus 1. The total number of duplex links are n into n minus 1 by 2. And the total number of input-output ports in each device are n minus 1. So, if the total number of computers to be connected is 10, then the total number of duplex links will be 45, and each device should have 9 input-output ports, which would be difficult to manage and also increase the cost. However, the dedicated point-to-point link eliminates traffic problems, which are encountered if a link is shared among several devices. The dedicated point-to-point link maintains privacy and security of the messages shared between two devices because other computers cannot hear what computer A is saying to computer B. If one link fails, it does not affect the whole network, that is good fault tolerance. Since each device is connected to every device, so installation is difficult. Multiple input-output ports and a large number of cables increase the cost and make it expensive. More cables in mesh topology consume large space too. Example of mesh topology is the connection between regional telephone offices. All topologies are interconnected to form a hybrid topology. Now, every topology has its merits and demerits. So, while choosing a physical topology for a network, we should always consider its cost, ease of installation, ease of maintenance, and cable fault tolerance. If you have learned something from this video, then please like this video. Share this video so that more people can learn. Subscribe to Tech Terms if you want to learn more and turn the notification icon on. Thanks for watching. Subscribe to Tech Terms if you want to learn more and turn the notification icon on. Thanks for watching.
What are network topologies? So that's what we're going to talk about in this video. Now, a topology is the layout of how a network communicates with different devices. And there are a couple of different categories of topologies. There's wired and wireless. So we're first going to talk about the most common wired topologies. And the most common wired topology that's used is the star topology. Now, in a star topology, all computers are connected to a central wiring point, such as a hub or a switch. All data on a star network passes through this central point before continuing to its destination. Now, one of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. The other computers would not be affected because each computer has their own. Another type of topology is called ring. The ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. Now, this kind of topology is very old and is rarely used today. Now, the advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And the next one is the bus topology. The bus topology is very old technology and, like the ring topology, it's not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is also fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. So if a computer is removed or if the terminators are loose or missing, then the cable would be open and then data would bounce back. And this bounce is known as signal reflection. And if this happens, data flow would be disrupted. And there is also the mesh topology. Now, in a mesh topology, each computer on the network is connected to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. Now, the advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other. However, because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks like the Internet. In fact, the Internet is a good example of a mesh topology, because the Internet is made up of numerous routers all over the world that are connected to each other to route data to their intended destination. So even if a few routers go down, the data will get rerouted using a different path to ultimately reach their destination. So the Internet is very redundant because it's using a mesh topology. So now we're going to talk about wireless topologies. So let's start with the infrastructure wireless topology. Now, this topology uses a combination of wired and wireless devices. Now, this is very similar to a star topology, where you have wired devices such as these computers here physically connected to a switch. And you also have a wireless access point that's also connected by a cable to the same switch. The wireless access point is here so that wireless devices such as laptops, tablets, cell phones, etc. can connect wirelessly to the network. So the wireless access point acts like a bridge between the wireless network and the wired network. Now the infrastructure topology is not limited to a single wireless access point. In fact, you can have multiple wireless access points if you want. It just depends on the needs of the network. And the next wireless topology is ad hoc. Ad hoc is a very simple wireless topology, and it's simple because it doesn't rely on any infrastructure such as cables, routers, servers, or wireless access points. All the devices in an ad hoc network wirelessly connect to other devices in a simple peer-to-peer network. They directly connect to each other without using a centralized device, such as a Wi-Fi router or access point. And because they directly access each other without a server or router in between, each device is responsible for its own security and permissions. Ad hocs are useful for setting up a quick wireless network on the fly where devices can share data without the need of an existing wireless network. And the last wireless topology is called a wireless mesh. Wireless mesh topologies are similar to wired mesh topologies, where devices are interconnected with each other, but with the exception that they are wirelessly interconnected. So for example, let's say you wanted to deploy multiple wireless access points all throughout a building so that wireless devices that are in different areas are able to access the internet. So normally you would have a modem that brings in the internet to the building, and then you would also have a switch that's connected to the modem. And then you would connect each wireless access point with a cable to the switch. So by doing it this way, this requires extra cabling, and it would also require extra time running the cables through the building. So this is more expensive and more time consuming. Now a wireless mesh topology would be similar to this setup, but without the need of these extra cables. In a wireless mesh, each wireless access point will talk to other wireless access points to create a seamless internet connection for wireless devices to connect to. So if this laptop over here wanted to access the internet, it would connect to the nearest wireless access point, and then this access point would relay the connection to the next access point, and then to the next one, and then eventually find its way back to the modem. So no matter which access point that you're connected to, you will still have internet access because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the other access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points. Because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the other access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points.
Okey, sekian, terima kasih. Kita selesai sudah berkenaan dengan topologi.